Okay, so this one, we must use ratio test, right? So always ratio test. Okay, so we have a rho equal to limit n approach to positive infinity, a sub n plus 1 over a sub n. So that will be n approach to positive infinity of 2 to the n plus 1, x to the n plus 1, n plus 1 plus 1, all over n plus 1 plus 9, and then times reciprocal of a second fraction, so n plus 9 over 2 to the n, x to the n, n plus 1, right? Okay, let's find out what we can simplify, right? So 2 to the n power, 2 to the n, well, 1 is there, and x to the n power, x to the n, 1 is there. Okay, then there will be limit n approach to positive infinity, 2 to the first power, and x to the first power, and n plus 2, n plus 9, over n plus 10 there, and then n plus 1, right? Okay, now we have distribute this one and distribute this one. We get 2 to the x, not 2 to the x, 2x. And then that will be n squared plus 2n plus 9n, which is 11n, plus 11 over x squared, I'm sorry, n squared, plus 10n plus 1n, which is 11n. Yeah, plus 10. Okay. So we have 2x. So 2x does not have an n, so we take out 2x. And then limit n approach to positive infinity. Okay, so we have terms. We have terms. We take the dominant terms from numerator and denominator respectively, right? So we have n squared over n squared. We simplify. Okay, so there will be 2x times 1, right? Which is 1, right? So limit of 1, which is 1. So this is a 2x with the absolute value, right? So how can we conclude that? Is it converging or diverging? It's a ratio test. We set up the rule earlier, right? So is it converging or diverging? Converging, yeah? Is it converging? Why? Because we make it less than 1, yeah? Okay. So absolute value, we said less than 1, right? Yeah, thank you, chat. All right, that means we set up without absolute value, and we make like that, right? So between 2x is between -1 and 1, right? Then we need to solve for x. Okay, so then we get divided by 2 every term. So we have a negative 1 over 2 x, positive 1 over 2, right? Okay, so in that case, It's converges, right? But then we want to know about all the x values. So is it parentheses or these x values include or not include, right? So -1, -1/2, +1/2, or -1/2, +1/2, or -1/2, +1/2, or -1/2, +1/2, like that, right? So parentheses, bracket, whether not include, include, not include, like that, right? So let us do this. Check endpoint. Convergence of the endpoint. So when x equal to -1/2, so we plug in into the x, right? Copy. So there will be summation n equal to 1 to +infinity 2 to the n, -1 to the n power n plus 1 over n plus 9. Yeah. Okay, so look, we have a 2 to the n, -1/2 to the n, so we can combine 2, so we can say that -2 over 2 to the n power n plus 1 over n plus 9. Okay, now we know that -2 over 2, which is -1, over n plus 9, right? Okay, now what kind of test, what kind of series we applied to know converges or diverges in the case? I'm gonna give you a hint. We have this one. It's alternative series test, right? Okay, so let us do this. Check the alternating series. Okay, then show a sub n plus 1 less than or equal to a sub n, and show the limit n approach to +infinity a sub n equal to 0. Okay, now we say the a sub first one. A sub n plus 1 less than or equal to a sub n. So a sub n plus 1. So we substitute into the n plus 1, right? So we don't carry this one, right? So we carry only that. So that will be n plus 1 plus 1 over n plus 1 plus 9. N plus 2 over n plus 10 is less than or equal to n plus 1 over n plus 9, which is a sub n. Is it true? Okay, then not sure, right? So maybe we might think n equal to 100. So 102 over 110 is less than or equal to 101 over 109? No, right? So this is actually greater than or equal to, right? Okay, so let's try show the limit n approach to positive infinity a sub n equal to 0. So there will be limit n approach to positive infinity a sub n equal to limit n approach to positive infinity n plus 1 over n plus 9. So we take the limit, then we take the dominant term from numerator to denominator. So we have n approach to positive infinity, n over n, which is, we had experienced a lot, so which is 1, right? So look, we have to show that equal to 0, right? But this is 1, so this is not equal to 0. So we cannot use alternative series test, right? Okay, then what we are using, since the limit is not equal to 0, then its divergence. It's divergent by divergence test. Okay. All right. So this is the same as positive 1/2. Same as x equal to positive 1/2. So we have that. So that would be n equal to 1 to positive infinity, 2 to the n, 1/2 to the n power, and n plus 1 over n plus 9. So there will be n equal to 1 to positive infinity, 1 to the n power, n plus 1 over n plus 9. Okay, so let's take the limit. So n plus 1 over n plus 9. So we have limit n approach to positive infinity, n over n, which is, we have a 1. So it's not equal to 0. So thus it's a divergence by divergence test. So we can conclude the interval -1/2, +2. So not included there, right? So if convergence and the endpoint is also convergence, then we include those points, which is the brackets, right? Since we check the endpoint, and those endpoint is divergence. So we don't include the endpoint, which is parentheses, right? Okay. Let's see. Differentiate. We have f of x equal to 1 over 1 minus x squared. And equal to 0 to positive infinity, x to the 2n. And we differentiate. So we have a summation n equal to 1 to positive infinity. So we drop the power, right? And reduce by 1. We drop the power. So 2n, x to the 2n minus 1, right? That's it. Okay. And number 3, we have used term by term differentiation. Find the power series. So we have f of x equal to inverse of tangent. So please looking at the lecture note. I don't want to review for this one, right? I will just show you how we get this one, right? So this will be we have inverse of tangent of x. The power series is n equal to 0 to positive infinity, negative 1 to the n, and x to the 2n plus 1 over 2n plus 1, right? So I explained to you everything before, right? So that will be n equal to 0, and then goes to positive infinity, and then negative 1 to the n. So instead of x, we have x to the third power, right? And then we are using 2n plus 1 all over 2n plus 1. So that will be negative 1, x to the, we distribute, then we get 6n. Oh, it's a power, 6n, 6n plus 3 all over 2n plus 1. Okay? Any question? So please look at the lecture note, how to differentiate, integrate to find power series, right? Okay. Let's do one number for this one. Number 4. So we have a Taylor, and so we have a 3x to the 4th power 3 e to the x power plus 4 e to the negative x power centered at a equal to 0, right? Okay, so the formula. So formula is summation n start equal to 0 to positive infinity. And then f of n over x over n, right? And x minus a to the n all over n factorial. Okay. But then Maclaurin series, when a equal to 0, right? Okay, so let's using the f of 0. So 3e to the 0 power plus 4e to the negative 0 power, what do you get? Please calculate. It's a 7. Thank you. How about f prime of x? F prime of x, what do you get? F prime of x, which is 3e to the x power negative 4e to the negative x, yeah? Okay, then f prime of 0, what do you get? Thank you very much in the chat. Very good. It's negative 1. Okay, f second prime of x. So we have a 3e to the x, positive 4e to the negative x. So f second prime of 0, then it's the same as the first one. So 7, right? Okay. So we finished the first 3. Now, they say that using this information modeling after example in the text, what is a polynomial? Degree 1. So they say that question, what is the Taylor polynomial of degree 1? Okay, so we have P naught P sub 0 over x equal to f over 0. P sub 1 over x equal to f over 0 plus f prime over 0 over x. Okay, so then there will be t sub, they give us this notation, t sub 1 over x. Then there will be p sub 1 over x. So p sub 1 over x, which is f of 0 plus f of prime of 0 over x. Okay, so we have f of 0, which is 7, f of prime of 0, which is negative 1 over x, yeah? So basically this is 7 minus x, okay? Now, they say that what's the t sub 2 over x? So Taylor polynomial over degree 2, right? Okay, then that will be p sub 2 over x, which is f of 0 plus f prime of 0 over x plus f second prime of 0 over x over 2 factorial, right? Okay, so that means t sub of x equal to p sub 2 over x. So f of 0, which is, so this one we have from the previous one, 7 minus x, yeah, plus f second prime of 0, we have 7 times 7 times x over 2 factorial, which is 2, yeah? I'm so sorry, I made a mistake. Is this squared? Squared. Any question? This number 4. Okay, number 5. So the Taylor series Taylor series for f over x equal to, we have e to the x and a equal to negative 2 is the series n equal to 0 to positive infinity c sub n x minus 2 to the n power is positive. Okay, so they said find the first few, it's not few, it's a lot, coefficient. Okay, so we are using the formula again, right? This is Taylor. Okay. Okay, so we knew, right? So this one we had experience earlier. So first one, second one, third one, sorry, I made a mistake again. Second prime, right? Second prime. And then over 2 factorial. And so third. And I want more fourth. Okay, so let us do this one. When a equal to negative 2, so f of negative 2, which is e to the negative 2, which is 1 over e to the second power, right? Okay, now f prime of a which is the same, right? That's why I did not do f of prime, right? So e to the x power, derivative of e to the x power, which is e to the x power, right? So e to the negative 2, which is 1 over e to the 2, right? Okay, now second, um, let's just ignore x minus a. Yes, because we need just a coefficient. So f second prime of negative 2. So we have 1 over e to the second power and then 2 factorial, right? Third, and 1 over 2 to the second power 3 factorial, which is 1 over e to the second power. What is that? 3 factorial. 3 factorial, 4 factorial. Can you please give it to me? Six and 24, thank you. So 6 and 24. Okay, so that would be, this is a C naught, C sub 0, and this is a C sub 1, this is a C sub 2, this is a C sub 3, this is a C sub 4. Okay? Don't make a decimal, more work, right? So just leave like that. Okay, number 6. Find the sum. Zero to positive infinity, x to 7. Ooh. Yeah, anyway, we have an n. 7n minus 3 over n factorial. Okay, let's note. So we had series n equal to 0 to positive infinity, x to the n over n factorial. This series we express as e to the x power. Okay? All right. Then let's do this one. So this one, we can split x to the 7n and x to the negative 3. Yeah? So there will be series x to the 7n, x to the negative 3 over n factorial. Okay. There is no n, so we can take out. So that will be x to the negative 3, x to the 7n over n factorial. Okay, so x to the negative 3 means 1 over x to the third, right? Okay, so x to the 7n we can express x to the 7 to the n power. Okay, now x to the, can you see that? We have I want to express this one better, right? So x to the n to the 7 power. How about that? That is better, isn't it? Yeah. Then we knew that will be e to the x power, right? I mean, with a series, right? So this is e to the x power. So we have x to the third, right? And then to the 7 power, right? Yeah. So there will be can you express it this way? Yeah. Okay. So let's make a 7 eliminating. Eliminating t, right? So we did that. X over t, which is a 3 square root over t, and y over t, which is 5t plus 7. Okay. So we can solve for t, this one. Then we have x equal to 3 square root of t. And we have square root of t equal to, maybe we can do it this way. X over 3 equal to square root of t. So x is square over 9 equal to t. Yeah. Okay. Now we substitute into the t. So there will be y of x squared over 9 equal to 5 x squared over 9 plus 7. That will be 5x squared over 9 plus 7. That is the y. That is the answer. Yeah. Okay. Number 8. Almost done. So find exact slope. So exact means fraction, not decimal. Okay, so we have x equal to 2 cosine t, y equal to a sine t, t equal to pi over 6. Okay, so slope. Also derivative, right? So this is a parametric equation. So slope, which is dy over dx, right? And then parametric equation, we have a slope, dy over dt, means that we derivative y in respect to t, right? Moreover, we're looking at the y equation, derivative with respect to t, yeah? So same concept with the dx over dt, that is y prime over t over x prime over t, right? So your turn. Can you please do that? So what's the y prime over t? What's the x prime over t? You guys there? 7 more minutes? Yeah. Thank you. So a cosine t over negative 2 sine t, that will be negative 4 cosine t over sine t. So when t equal to pi over 6, so the slope is negative 4 cosine pi over 6 over sine pi over 6. So what do you get? Cosine pi over 6. I think we did that earlier, right? So square root of 3 over 2 over sine pi over 6, which is 1/2. So negative 4 square root of 3 over 2, which is negative 2. Negative 2 square root of 3 times 2 over 1, right? So that is negative 4 square root of 3. Okay, number 9. So determine the slope of the tangent line. The tangent line. So we went over this one in the class. Determine the slope of the tangent line. Find the equation basically. And then how about find the equation of find the equation of tangent line, right? And t equal to negative 1, x equal to 4t, y equal to t to the 6th power. Okay, so we have to find the slope. And then we give it to the equation of a tangent line, which is y equal to mx plus b form, right? Okay, the slope. Your turn. Can you please find out slope? So let me just simply write down. So what do you get? Y prime over t, which is dy over dt. And x prime over t. Thank you. So 6t to the fifth power over 4. Excellent. So when t equal to -1, what is the slope? So 6, your turn. Please calculate. Excellent. -3 over 2, right? Okay, now we have a point slope form. So we have y minus y sub 1 slope x minus x sub 1. Okay, now when t equal to -1, x of -1, 4 times -1 is -4, and y of -1, -1 to the 6th power, which is a positive 1, right? Okay, so there will be y minus 1 equal to slope, which is -3 over 2, x minus plus 4. Okay, so y minus 1 equal to -3 over 2x minus 12 over 2. So y equal to -3 over 2x minus 6 plus 1. So there will be -3 over 2x minus 5. So this is the equation of tangent line. And this is the slope, right? Okay, the last one, we just did a convert, right? Convert the Cartesian six three to polar coordinate. The theta is between 0 to 2 pi. So we knew this means xy, right? The goal is r theta. Okay, then we have the formula r squared, which is x squared plus y squared. R equal r equal to x squared plus y squared, right? We only need positive, right? Okay, now x squared, which is your term, please calculate what you get. It's a 3 square root of 5. Thank you. And now we want to find theta. So tan theta, which is y over x. So that will be y, which is 3 over 6, which is 1/2. Okay, so can you please do that? Inverse theta equal to inverse of 1/2. Can you please calculate? Then we are done. The radians? Point 464. Thank you very much. Any question? Thank you very much.